So with arithmetic sequences, we can write a rule for each of these, and they're going to be set up the same. And so the nth term of an arithmetic sequence with first term a1 and common difference d is given by an is equal to a1 plus n minus 1 times d. So this a sub n, that is your nth term. A sub 1, that is your first term. And d is your common difference. And so that means that we can use this rule to find any term that we like. And so, for instance, let's say I wanted to find the 51st term. I can just plug in 51 for n into this formula and plug in what a1 is and d is, and that will find my 51st term. And something else that we notice with this is that this is actually a linear function. So if I were to go ahead and distribute the d in there, and rewrite this, I have an is equal to dn plus a1 minus d. And so you can kind of compare this to y is equal to mx plus b, where d is kind of like your slope, and this a1 minus d is your y-intercept. So let's go ahead and go through some examples of writing a rule. So we're going to write a rule for the nth term of a sequence, and then we're going to find a15. Again, that a15 means we're finding the 15th term. So to write the rule, I need to first identify what my first term is, and I need to identify my common difference. Well, my first term here is 3, so I know that a1 is equal to 3. And then my common difference, I see to get from 3 to 8, I add 5. 8 to 13, I add 5. And add 5. So d is equal to 5. And now I'm going to go ahead and plug that into my rule. So a1 I found was 3, and d I found was 5. And now I'm going to go ahead and distribute that 5 and write it where it's in that y equals some number n plus or minus another number. So distribute this 5, and I get that this is equal to 3 plus 5n minus 5. And combining like terms, I get that an is equal to 5n minus 2. And then it asks me to find the 15th term. I'm going to find a15. So that means wherever I see an n, I'm replacing it with 15. And so I get 5 times 15 minus 2. And when you do that, you get that a15 is equal to 73. Okay, let's do one more. Here I have the sequence 55, 47, 39, 31. And so here I see that I am subtracting 8 each time. And I see that my first term is 55. So a1 is equal to 55. And d is equal to negative 8. And so I want to plug that into my rule. So an is equal to a1 plus n minus 1 times d. a1 is 55 plus n minus 1 times d, which is negative 8. Distributing that negative 8, I get negative 8n plus 8. And so my rule is going to be an is equal to negative 8n plus 63. And then lastly, I want to find a15. So instead of n, I'm going to replace that with 15. So I have negative 8 times 15 plus 63. And when I simplify that out, I get negative 57.